me share this. Real light. All right. Chapter 12. Chapter 12 deals with vectors and the geometry of space. Section 1 deals with three-dimensional coordinate system. Originally, in algebra, we talked about a two-dimensional space. If you think about it, when we first began learning math, we started off with a number line. We had 0 in the middle, positives to the right, and negatives to the left. Goes to negative infinity and positive infinity. Then, René Descartes introduced us to the two-dimensional realm. We have a y-axis where going up is positive, going down is negative. Can anybody guess the history behind this? What he was doing when he invented this coordinate system? That's why this is called the Cartesian Coordinate System, after René Descartes. He was sick in bed one day. This is back in the 1600s. And their roofs, the ceilings were made of these matrix of timbers. He saw a spider walking up there. And he says, wow, I can tell you exactly how far and where that spider is from that corner by counting how many bars this way, how many bars this way. And from there, he said, everything that we could look at could be done that way. That's where he invented that. Then comes another evolutionary development, three-dimensional. This is actually three-dimensional. If we put a stick right there, that's the z-axis. So if we have a point here on 2, 3, and if we lift that point up here, then we have a point at 2, 3, say 5. Now we have three dimensions. The coordinate points used to be x, y. Now we're going through the three-dimensional, x, y, z. How do we look at this? If we were to draw a three-dimensional graph, how would it look? This is our x-axis. One, two, three, 4, 6, and so on and so forth. This is our y-axis. And backwards is negative. And to the right is negative, or to the left is negative. And the z-axis goes up and down. Up is positive, down is negative. Now, why is this the case? If you, let's pretend this is our x-axis. If you put your hand out straight like this, that's your fingers are pointing that way. Your thumb is the y-axis. It's going straight up. The z-axis, I mean. Now, if you close it, the direction in which your fingers are turning from the x to the y-axis so we call that the right-hand rule. So from the x-axis to the y-axis, with it, this one, so that's the y-axis. This then has to be the z-axis. So whenever you look at something, find the x-axis, and if you go counterclockwise to the y-axis, that's a right-hand rule. In this one, the y-axis is going this way, I close my fingers, and there's the y-axis. The thumb goes up. The left-hand rule, same thing. If I follow where the x is and I go where the y, the thumb goes down. So the left-hand rule is just the opposite. So if you talk about left-hand rule, if the thumb went up on left-hand rule, it would be x here. That would be the positive direction. So you follow your hand the way it rotates. This is going to be important because everything we're going to do from here on out follows the right-hand rule. So when you go from x to y, that's the positive rotation. The y-axis goes up. Let's talk about planes on three-dimensional realm. Remember, in a three-dimensional world, we have three axes, x, y, and z. If I said x equals 3, what would that look like on a graph? Is it just a line? Oh, yes, it'd be a ball. Yes, it'd be a plane. Because remember, this is your x, this is your y, and that's your z. So if x is 3, that means everything else going from that point up and down and out, it would be a sheet crossing through 3. Because no matter what x and y you have, the y and z's you have, x is always 3, so it's always going to be that one sheet crossing x at 3. It's going to cross there. Again, now you see the most difficult part about this course is trying to imagine things in 3 dimensions. Drawing things are even more difficult because you have to remember, since the y-axis is this way, it has to be parallel to that. The x-axis is this way, you have to make sure, and the y-axis, z-axis is that way. So that's our plane crossing. So if I had a plane at y equals 5, there's 5, yeah. So through this point, the sheet would cross through that point, and it would be everywhere around that. It's just took a piece of paper, put it there on 5, and you're done. If z equals 0, what do we have? We have flat sheet where? The xy plane, right? At the origin, yes, going through the origin, but since it doesn't go up or down, it's just the xy plane. Mm-hmm. If y equals 0, what do we have? Xz plane, right? So you have to look at where the x is. So it's going this way and up. such a sheet following on the x. And if x is equal to 0, we have the YZ plane. What if x, y, and z all equal 0? What point would it be? It'd be the intersection of all three of these, because we know that if x is 0, we have the YZ plane. So that has to equal the XZ plane, and then the XY plane. And the only place they're all equal to 0 is at the point 0. So that's the only time if you have all three at 0, that's a point, a single point. Everything else above that, see, if the XY plane met the Z plane, what would that look like? What's that? If I had the XY plane, what does the XY plane look like? It's a flat, yes, 2D plane. What does the Z plane look like? It's the vertical. So it's that flat 2D space going up and down. So here we have a box or column or box going up and down to infinity. Because you take your XY sheet, which is a 2-dimension, and it goes up and it goes down. What if we had this? What would that mean? That's a single point in 3-dimensional space. But how is it created? Now, yes, it's exactly what we have. But remember, each one of these coordinates, each one of these components are made up of sheets. When x equals 2, that's that, or the sheet crossing x-axis at 2, the sheet y crossing at 3, and then at z. Because if you just had these two, what would you have? If you just had x equals 2 and x equals 3, what would you have? What would the intersection look like? It'd be in the first quadrant, yes. Well, actually, remember, that changes a little bit. Yes, it would be in 2-dimensional space, it'd be in the first quadrant. Remember, we have 3 dimensions. So now we have 8 octants. Okay. Right, yes. Now, for these guys, if I said x equals 2 and y equals 3, if I intersected both of those, so this is my x, this is my y, and this is my z. If I had x at 2, that's a sheet. That's a sheet at 2, and y at 3. So they would intersect here. It'd be a line. When two sheets intersect, it'd be a line, yes. Whenever two separate planes intersect, you have a line. When we have a third sheet now, it now intersects, it's a unique point in 3-dimensional space. So that point. And this, out of anything, will be what makes this course so difficult. There's 2. There's 3. There's 5. So what we have to do here is we have to go now up 5, because it has to follow this. So it goes up. There's 1, 2, 3, 4. Again, that's going to be the most difficult part about this course, is picturing if there's if you think about a corner in a room, there you have the X and Y axis on the floor, and the Z axis goes up. So if you go 2 feet out that way, 3 feet out this way, 5 feet up, that's what this means. Yeah, so once you can start picturing this, now we start doing rotations, we're going to have spheres, we're going to have eggs, actual eggs, ovals, and we'll have concave forms and shapes. So yeah, in a 3-dimension space, you have octants. For example, the first octant, all 3 are positive. Why do we have an octant? Because think about it. You have the X and Y plane, right? The X and Y plane gives you 4. This is the first one. This is the second one, third one, fourth one. And then you have up, which are the positive, 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 and then the negative Z's. So that's why we have 8 octants. And you can look at here in this first box up here, all 3 are positive. What's in octant 2? Well, you have X is negative, Y is positive, and Z is positive. And then in octant 3, you have negative, positive, and so forth, so forth. So it all depends on the signs of each relative each plane of where which octant you're in. If the third one is positive, you're above the X and Y plane. If the third one is negative, you're below the XY plane. All right, let's look at these. Interpret these equations and inequalities geometrically. When Z is greater than or equal to 0, what does that look like? Yeah, everything above the XY plane, up. So it's that square going up. How about X equals -3? It's just a sheet crossing the x-axis at -3. It goes on infinitely everywhere else. There you go. Y equals 0, or Z equals 0, X less than 0, and Y is greater than 0. Right, so it would be just that sheet in the second quadrant of the XY plane. So it'd just be this area here. X is less than negative, and Y is positive, so I'll do that. This one's a sheet through X. How about all three of them being greater than 0? It'd be the first octave, right? It would be everything here up and down. Go on forever, up and down, in this first octave, going up and down. Y is between -1 and 1. Right. So here's the Y. So it's from -1 to 1. It's just that, yeah, up and down. It'd be a slab, actually, not a sheet, because it's that thick, going back and forth. Yeah, so it'd be a slab. It'd be that thick slab from -1 on the Y-axis. Y equals -2, X equals, or Z equals 2. Remember, what does Y equals -2 represent? Yes, it'd be a line where both of these intersect. Yeah, because each one of these are their own. So when Y equals -2 and Z equals +2, it'd be the line where both of those intersect. So that'd be a sheet like this, and a sheet like this. So it'd be a line parallel to X. Yes, this is, again, this is why I want to do this also, because we have to, it's hard, it's the boom, blew my mind. It's just being able to see this stuff like this makes it difficult. Here's another one. What points X, Y, Z satisfy the equation X squared plus Y squared equals 4 and Z equals 3? Okay, let's look at this. What does this equation represent? The circle. Very good. Circle with radius of 2. Notice whenever you're doing these X and Y hash marks, on the Y-axis, I make them parallel to the X-axis. Let's see like this. So they have that same angle. Same thing with the X-axis. I make them parallel to the Y-axis. So there is that's my circle at X squared plus Y squared equals 2 squared. That's the radius. And now what does this mean? Right, so at 3. So now I lift this circle up 3 spaces, and now this circle is going to be up here. No, because this is a single point. Remember, this is a sheet. It's a horizontal sheet at Y as Z equals 3.
What he's saying is because you have the C3, then they cut
that cylinder. Yeah, this would be a cylinder. If we didn't have this, it would have been a cylinder. Yes, because Z is everything. Right. Now, since I limited what Z is equal to, I cut that right there. Okay. How about the distance and sphere space. Remember, in 2D, in a 2D world, distance between 2 points. P and Q. What is P made up of? If you have 2 points in a 2D world, this is made up of an x1, y1. This is made up of an x2, y2. So how do we find the distance between those 2 points? What's the formula I use? Actually, this. Is that familiar? Pythagorean theorem. The Pythagorean theorem serves a lot to us. It tells us the hypotenuse, or the length of the legs of a right triangle. The hypotenuse represents the distance between the 2 points that you're looking at. It also defines what else? Equation of a circle. X squared plus y squared equals r squared. So the Pythagorean theorem has a lot of uses. So the distance that we have to do using this, that's the distance between our 2 points. It's made up of x2 minus x1 squared, y2 minus y1 squared. And square root both sides. So that's what we did in algebra. Now we take it one step further. In the 3D world, now in the 3D world, we have 2 points. We have point 1, which is made up of x1, y1, z1. And we're going to get point 2, or make it q, which should be x2, y2, z2. So the distance would be what? x2 minus x1 plus y2 minus y1 plus z2 minus z1. But we don't write this. This differentiates us from a 2-dimensional, 3-dimensional world. Is because distances cannot be negative. So using these absolute value signs, what we're looking at here so that's our formula for the distance between 2 points in 3-dimensional space. It's an example here. Find the distance between these 2 points. Here's 0.1 is made up of 2, 1, and 5. 0.2 is made up of negative 2, 3, 0. 0.1, the x component is 2, y is 1, z is 5, and 0.2, x negative 2, y is 3. So the distance between those 2 points, x2, negative 2 minus 2 squared, y2 minus y1, 0 minus 5 squared. Now we'll just do the algebra. Negative 2 minus 2 is negative 4 squared. 3 minus 1 is 2 squared. 0 minus 5 is negative 5 squared. Negative 4 squared is 16. 2 squared is 4. Negative 5 squared is 25. Is 9 times 5. Square root of 9 is 3. 3 out of 5. I would be happy with that, but I think your textbook, your My Math Lab, would want decimals. Will take this? Okay.
Yeah, I did this. You can put it into one.
Okay, good. Because this is more accurate than any decimal you put in there. Yeah. It's just excellent. So that's distances. Again, we use the same formula. Remember I told you that the Pythagorean theorem also works for circles? Equations for spheres of radius r and center x sub 0, y sub 0, z sub 0. This is Pythagorean theorem for two-dimensional space. For three-dimensional space, we just add another dimension to it. So the distance squared is x minus the origin, y minus y0, z minus 0 squared. Why don't I do the square root on it? Yeah, because I'm looking for the radius r. This is the radius. So d is equal to the radius. The center is at, so here's how you find the center. It's always the opposite of what's the side of the equation. So if I gave you, let me see, example. If I gave you this, x squared plus y squared plus z squared plus 3x plus 4z plus 1 equals 0. Find r and c. Now here are the steps. What's the first thing you got to do? First off is rearrange the values into groups. Put all the x's together, the y's together, and the z's together. So here's an x. There's an x. There's the y. Basically, what we have to do here is we have to complete the square 3 times. So we group all the terms together. Move the constant term to the other side. So we have x squared plus 3x plus y squared c squared minus 4z equals -1. So I'm going to move that over. So subtract 1 from both sides. Remember how you complete the square? Add b over 2 squared both sides. We had ax squared plus bx plus c. So whatever is in front of the x. So I add b over 2 squared to this one. I have to add it to this side also. I have more space. This one doesn't have a b, so nothing. Or over 2 squared. So since I added these two, I got to put those over here. Complete the square. How do you complete the square? Well, on the left-hand side, you don't have to do anything inside here. Just use whatever's inside the parentheses and the first sign. We have x plus 3 over 2 squared plus y plus, since y doesn't have one, it's y plus 0. And z, use the first sign. 4 divided by 2 is 2. All I use is the first sign and whatever's inside the parentheses. And the whatever's x. Basically, whatever's under the squares are the numbers, and whatever the first sign is. Whatever's under the squares and the first sign. On the right-hand side, we have to work it out. So we have -1. 3 over 2 squared is 9 over 4. 4 over 2 squared is 4. So it's -4 over 4 plus 9 over 4 plus 16 over 4. 21 over 4. So far, so good? Now find the values. Whatever the sign is, your x component is the opposite sign of that number. So it's negative 3 over 2. Y is 0. Z is positive 2. So the center is at negative 3 over 2, 0, 2. That's what those are. The radius is the square root of whatever this answer was here, 21 over 4. Square root of 21 over square root of 4, so the answer is square root of 21 over 2. It's the same thing we did in algebra, except now we have one more term, the z term. It takes a little bit longer. I know it's been a long time since you guys were in algebra, so that's the hard part. Calculus 1, 2, and 3, in essence, are not difficult subjects. Once you start doing the process, that's all the calculus there is. The rest of it is algebra or trigonometry. That's the hardest part. That's where more mistakes happen. Calculus is simply the first step. Everything else after that is algebra. All right, let's see what else is pretty. Oh. Geometrically, interpret these values. What does the first one represent? Right. It's a sphere. Because it's 3 dimensions, it's a sphere now. It's less than 4, so it's everything inside the sphere. Two, 3, 4. 3, 4. 4. It's the X and Y part represent a circle. Let's look like a sphere. It's a ball. What's the second one look like? And the sphere, the shell itself. Right. So it looks like this, but this one would have on the shell would have a dotted line because you can't use it. This one would have a solid outer shell because you can include it. It's equal to. These two are identical. The only thing difference is the outer limit. How about this one? Everything outside the shell, right? So if you had an air bubble inside, like when you're cooking bread, you have an air bubble inside there. That's what that represents. X squared plus y squared plus z squared equals 4, with z is less than equal to 0. The bottom half of the sphere, right? We can only use the xy plane, but that's when it equals 0, and then below there. So it's the bottom half of the sphere. What do you think? That's it for section 2, 12.1. Next time when we meet, we're going to go to 12.2. How many of y'all have taken physics already? So here we have what's the difference? Very good. That's exactly right. Yeah, magnitude. Both magnitude and direction. That's what we're going to cover next time. Because now, since we deal with real numbers, all the rules of algebra apply here. I mean, we can add, subtract, multiply, divide these things. And that's what we'll do next time. So, again, I'll leave it up to you all. Show up if you want. I'll be here on tomorrow. Or you can watch it online. I will tell you if I'm moving a room, because I don't like this room anymore because I can't plug in my laptop. And it's not fair to everybody on TV land. So if worst case scenario, I'm going to move into another room, a different floor. I'll let you know tomorrow where I move for sure. So make sure you're using the app. Okay? All right, everybody.